Hi everybody, welcome to another episode by the Opinionated Science Educator. Today I'm going to be comparing the Physical Sciences CAP curriculum with the Technical Sciences curriculum. That is so that anybody who is doing technical sciences and requires support or help can know what sections are new and how the rest of the curriculum has been rearranged within the Technical Sciences curriculum. In this third and last video, we will start by looking at matter and materials. In the physical science curriculum, the section on matter and materials is covered in grade 10, 11 and 12, whereas in the technical sciences curriculum, it is only looked at in grade 10, skipped in grade 11 and looked at again in grade 12. So let's have a look at what content or concepts are taught in matter and materials in the technical sciences and compare it with that of the physical sciences. Both curricula start out by looking at the classification of materials, pure substances versus mixtures, the properties such as electrical conductors, those substances that are magnetic or not. What is different is that in the technical sciences, included in this section is the balancing of chemical equations. There is more emphasis, it seems, on thermal conductors and insulators and magnetic and non-magnetic materials. Now, both curricula look at atomic structure, the particles that make up matter. In the physical sciences, though, there is a little bit of focus on the kinetic molecular theory by looking at solids, liquids, and gases. Both curricula focus on the structure of the atom and things like isotopes and atomic structure. In the physical sciences, there's also an introduction to chemical bonding, which is missing from the technical sciences. Now, the properties of many materials depend on the type of bonds that form, so its absence is slightly glaring. For example, there's no focus on molecular structures or ionic lattice structures or covalent lattice structures. So the fact that chemical bonding isn't there is a little bit concerning. Then in grade 11 in matter and materials, molecular structure is looked at, including the polarity of bonds and molecule structure, as well as intermolecular forces between particles, and then looking at the gas laws and ideal gas laws. But this is not done in the technical sciences. The fact that intermolecular forces aren't looked at is also a little bit concerning because they play an important role in the properties of many organic molecules. And looking at ideal gases is important for understanding work in gases. Then in grade 12, both curricula look at organic chemistry. And it seems as though both curricula focus on the same concepts and the same content. But as I mentioned, the fact that the technical sciences does not look at intermolecular forces might make this section a little bit more difficult to understand. And then something that is in the physical sciences that is not in the technical sciences is the optical properties of materials, such as emission ray, emission spectra, absorption spectra, and particularly looking at the photoelectric effect. Now, in the technical sciences, photovoltaic cells are looked at in alternate energy sources. And that basically is the same content, looking at the photoelectric effect, why some materials will conduct electricity in the presence of light. So that's where there is some difference. Now, what is new in the technical sciences is looking at the electronic properties of matter. So what semiconductors are, the type of semiconductors, and so on. And semiconductors play an important role in diodes, so P and N junction diodes. So as I said, this is new in the technical sciences. It is not taught in the physical sciences. Although this section was in the original NCS curricula, which was amended when CAPS was brought out. So, as I said, the key difference is that matter and materials is taught over 3 years in physical sciences, where it's only looked at over 2 years of the technical science curriculum. But there are some sections which I think it was a mistake to omit, such as chemical bonding and intermolecular forces, because those play an important role in understanding the properties of many substances. Now let's look at the last section of chemical change. Again, chemical change is looked at in grade 10, 11, and 12 in the physical sciences, but it is only looked at in grades 11 and grade 12 in the technical sciences curriculum. Now, there is a huge section of the grade 10 syllabus that focuses on the difference between a physical and a chemical change and representing chemical change, such as in balanced chemical equations. But as I said, balancing chemical equations is brought into the matter and materials. I just don't know if there'll be enough time or a context to understand the balancing of chemical equations. What is also looked at here is the aqueous solutions, reactions in aqueous solutions, which is looked at in the technical sciences as electrolysis. So hopefully the technical sciences will also look at dissociation reactions, which are key for solutions and electrochemistry. The technical sciences does not look at any of the stoichiometry. So nothing about the mole, about molar relationships, and so on. Then in the physical science, different types of reactions are looked at, such as acid-base, redox reactions, and so on, including for redox oxidation numbers, whereas in technical sciences, only oxidation and reduction reactions are looked at, which makes sense in terms of understanding the electrochemistry, but acids and base reactions are also very important. In the technical sciences, the rate of chemical reactions is not looked at, neither is equilibrium, and there is no chemistry in the technical sciences about acid and base chemistry. So those then really are the key differences. Then in grade 12, in the physical sciences, electrochemical reactions are looked at, such as electrolytic cells, voltaic cells, and different electrochemistry processes, which is also looked at in the technical sciences curriculum. And that relies on oxidation reduction reactions. So it makes sense as why chemical change focuses only on oxidation and reduction in the technical sciences. But acids and bases will also conduct electricity because they also break up into ions. So that is a summary then of the chemical change knowledge area in both curricula. As I said, it's covered in 3 years in the physical sciences, but it is only looked at in 2 years, grade 11 and grade 12 in the technical sciences curriculum. Now, what is new in the technical sciences curriculum is that focus on alternate energies, which include biofuels and the fuel cell and the photovoltaic cell. So that section is new, although, as I said, the photovoltaic cell is covered in the physical science curriculum too. I would just like to touch on the knowledge area that's not included at all in the technical sciences, and that is chemical systems. Chemical systems basically looks at, in the physical science curriculum, the hydrosphere in grade 10, the lithosphere, which is important for mining and energy resources, and then the chemical industry, such as the fertilizer industry. Now, the fact that chemical systems are not looked at as a whole in the technical science curriculum and is missing is a little bit concerning for me, basically because of the underlying aims of the South African curriculum. Now, as I said, the hydrosphere provides the water that we need, and water purification is an important process. Mining is an important process that often results in pollution. The use of fertilizers often results in pollution. And anybody in the technical or technological field who doesn't consider environmental aspects, for me, as I said, is concerning. One should consider, and one has to do things like environmental impact assessments when planning to develop a new mine or so on. So one of the critical aims of the South African curriculum is that students learn that science and technology should be used with responsibility towards the environment and the health of others. So the fact that there's no clear focus on chemical systems is, as I said, a little bit disconcerting. But it is there to some extent in the chemical change by looking at alternate energies, such as biofuels, fuel cells, and so on. Well, folks, that's my summary of the differences between the technical sciences and the physical sciences. So I hope that you found this video useful in comparing the two curricula. And if you're doing technical sciences, I'm looking forward to posting videos on some of the topics. There are topics that are interesting and practical and applicable to our everyday lives. A particular topic that you feel you really need help with. Subscribe to my channel, and in the comment section, just post a comment telling me which topic you'd like me to look at. So until next time, the Opinionated Science Educator signing off.